Hey everyone, I'm David, aka Coma2000. Welcome back to my channel. I know a lot of people are looking for beginner tutorials for VCV Rack, so here's my attempt. I hope you find it useful. And once you're done watching, please let me know in the comments what aspects you would like to hear more about, and also please consider subscribing so you don't miss any future tutorials, which I will definitely make in 2024. I hope you have a good new year. In this video, we'll be going over the basic components of a synthesizer, in our case, virtual and modular, including VCOs, LFOs, envelopes, and so on, and we'll learn how to build patches in VCV Rack version 2. Don't worry if you don't know what any of these terms or abbreviations mean, we'll be going over them in this video. And a synth patch is just a combination of these before mentioned components, which we call modules, and they are connected with cables. This setup can then be recalled, reloaded, to produce specific sounds. In VCV, you can save them as .vcv files, and you can open them whenever you wish in the VCV Rack software. In this video, we'll start by installing and setting up VCV Rack. Then we'll have a quick overview of the concept of synthesizers, modular synthesizers specifically, and then we'll go over the default patch that loads when you open VCV Rack version 2. We'll also look at how to install custom modules. At the moment I only use free modules, so that makes your life easier too. By the end of this video, you will be able to make sounds with VCV Rack, and you will even be able to record them so you can show it to your friends and family or just for yourself. This video is timestamped, so feel free to jump ahead if you already know some of this stuff. Of course, I would prefer if you went along slowly and even stopped the video built along, but with that in mind, let's get started. First, we have to install VCV Rack, so we go to the VCV Rack website, and you can see that Rack 2 is now available, so we click anywhere here. And now we click on Get Rack 2, and depending on your operating system, you choose the appropriate download. I have a Mac with an Intel processor, so I will click on macOS x64. If you have one of the newer Macs with the M chips, then you click ARM64, otherwise Windows or Linux. And now we are downloading the installer. You can see it here, and depending on your internet speed, this will happen quite quickly. Unfortunately, my internet is quite slow at the moment, but it's a very small file, so no problem. We double click on that. And now we just follow the steps. We click continue and install. You might have to enter your username and password. I will abort here, but if you don't have VCV yet on your computer, please pause this video and install it now. I assume you have installed VCV 2 on your machine now, so let's open it. And once you open VCV Rack 2, you see these useful tips and tricks, which you should definitely toggle through some other time. So for now we will close this message, and the window that's in front of us is resizable and you can move it around. You can even go full screen. We will actually do that right now. And in front of us is the basic layout, which is a patch that has already been built for us. It's a complete synthesizer with which you can actually make sounds. We have individual modules that are connected together by cables. Hence, this is a modular synthesizer, and you can reposition these individual modules with the mouse. And in VCV 2, you can even select multiple modules and move them together. You can also copy-paste modules. So by clicking on the VCF, for example, I press Ctrl or Command C and then click somewhere else, and then press Command V, and now we have another VCF. and you can do this again and again if you want. You can also delete modules, so you just click on them or select them and then press the backspace. Or you can right-click on the module and then from this local menu you can select delete, and you can even see the keyboard shortcut next to it. Let's go over what is in front of us. It's a bit difficult to see at first glance what's exactly happening, but we will go module by module. However, in order to record the sound from this patch, we'll have to add the recording module. In order to add a new module, you have to right-click or double-tap on the trackpad. And now we see a list of modules that are available to us. These are all the VCV branded modules that come stock with VCV Rack when you first install it. And if we quickly look through these modules, we see that the recording module is missing. So in order to get that, maybe we'll have to update our library. If you go to the library menu, you see that you first have to register a VCV account. So let's try to do that. So we input our email address here, and then we set a password. So let's set a random password. And now we click register. And now we are logged into our account, so we can add new modules from the library. However, we have to first sign in on VCV Rack, so let's go and do that. We are in VCV Rack now. So we go to email, we write our email here again, and we sign in with our password that we just provided, and we are logging in. And you see that the VCV free modules can be updated from 2.5 to 2.6. So we click update all. And now all plugins have been downloaded. Close and relaunch Rack to load new updates. We will do that. So we have relaunched VCV Rack now. Let's see if we have a recording module. We double tap, and well, I don't see any recording modules here. So we'll have to go to the library now, online, in the web browser where we registered. Now we are in the browser and we'll look for VCV branded modules. Here they are. And let's check which modules are free and which we don't have. These are all included. And here is the recording module. We'll have to add that. It's not included in the standard distribution. So we click add. Let's see if we have anything else missing. Seems like we have everything apart from the recording module, so we now have that too. We go back to VCV Rack and we check if we have any updates. We should have some. And yes, we do. We have the VCV recorder now, so we update all again. It's downloading, you can see. And now we will relaunch again. So we double tap. And now we see the recorder module, which records stereo, audio, and video to a file. Wow, also video. That's something new in VCV too. Well, we'll add that now, so we click on it. And it has been placed here. As we know, we can move it around by clicking on it and dragging. And now what we need to do is we have to find the final sound output and connect it to the recorder? Well, our final module is our audio module, from which the sound goes to our computer and then through the earphones or headphones or speakers into our ears. So it is coming from this low-pass filter, so we are going to connect exactly that output to the left input of our recorder. In order to place a new cable, you have to click on one of the inputs or outputs, so let's click here and hold the mouse button clicked and move it to wherever you want to on top of an output. And usually outputs are labeled black and inputs are white, so you can see that this is from black to white. And once you're hovering on top of it, you can let go the mouse key, the mouse button, and it will place it there. Seems to be working fine. Well, we'll see. But in order to start a recording, you'll have to click here. But first, if we right click, you can see many options here. First, you can select an output file, so we have to do that. The location where this audio will be saved, so we select. And then, let's say in recordings, we will call it untitled. And now, if we right-click again and keep on looking at the options here, we see that we are going to save this in WAV format, which is lossless and uncompressed, so it's fine. And no video in our case. I am actually recording the video through the QuickTime app on my Mac, but maybe we can try this too one day. And we can set the sample rate here to 44.1 kilohertz or 48 kilohertz and the bit depth from 16 through 24 to 32 bits. Well, let's just leave it as it is now. And if we hit record, it should start recording all the audio, noise, music, whatever that this patch produces. So let's hit record now. The recording module is recording our sound into documents, Rack 2 recordings. At least that's how it is on my Mac, and you can see the untitled file here. So if we go back to VCV Rack and stop this recording and go back to our files again, we can actually play this recording back. So we'll do that. I think it will open it in Apple Music for me. And now it's playing back. You can see that we have 26 seconds left, and obviously it sounds like nothing because we haven't recorded any sounds. Let's now go from the very end of the patch to the very beginning, where we can find the notes module. Here we are actually given some instructions for this tutorial patch. The first being, choose an audio driver and device in the audio module. Well, the audio module is right here, and this is where we will select the device. But first, let's finish talking about the notes module and what you can do with it. Well, as the name suggests, you can take notes with it. So you can type anything you want here, or you can even delete text. This can be quite useful if you want to take notes for yourself, so when you open your patch much later, you can remember things that you want to remember, or for other people if you decide to share your patches. For example, how to set various parameters or how to start the clock. Let's go back to the audio module and let's select our audio driver and device. You have to click on No Device and select the appropriate audio device that you wish to use. Well, I have a lot of options here because I have some crazy audio routing on my computer and I have Pro Tools installed, which just adds all of these here. I have Soundflower, I have Loopback, I have all sorts of stuff that you don't have, probably. So just select built-in output, and that will play the sound on your speakers or on your computer, in your earphones, in your headphones, wherever. And now, the question is, do we have sound? But let's start the recording again and try to play some sounds. Something I forgot to mention is that on the audio module, if you click here and scroll down, you actually have further options beyond the sample rate, and that is the block size. The higher you set the block size, the less strain you put on your processor, so it makes it easier for your computer to work with VCV Rack. By default, I think it's set to 256, which means 5.3 milliseconds of latency, so you get some audio delay, but that's minimal. And if you set it higher, the delay will be longer, but that's not a problem for us. However, if I increase the block size, that might make it easier for my computer to record this video. So I'll do that. We are done with point 1 of the instructions in the notes. We're good to go and make music. In point 2, the instructions say that we should use our keyboard to generate MIDI notes, which are then converted to 1 volt per octave and gate signals. This is actually happening in the MIDI to CV module, where we are using our keyboard in order to generate 1 volt per octave pitch output that goes to the VCO and gate output, which goes to the ADSR envelope generators. But let's not get ahead of ourselves and just follow the instruction in point 2 that says that we should use the bottom row of our keyboard to make some sounds. So let's try that. My keyboard starts with a Z key because I'm using a British keyboard. So let's press that button now and hear if we have sound. Oh yes, oh yes. We can actually turn the level a bit further down here on the audio module and play some music. Well, that's it. Of course, you could also plug in your keyboard into your computer via USB or through an audio interface. You know, the one that looks like a piano, and you could play on that instead of your computer keyboard. There, of course, you could play much more expressively. For now, this doesn't really matter. The fun with synthesizers, and for which they were invented, is that they allow us to create instrument sounds, electronically, artificially, like the one you hear here. So whatever this sounds like. They can sound like real instruments, such as drums, pianos, flutes, wind noise, guitar plucks, whatever. And sometimes you want them to sound as close to real instruments as possible, while other times you want them to sound obviously electronic in order to create unique sounds. Now let's have a look how it's done here in this patch. You don't have to understand much yet. This is what we are actually going to learn in this video. What is an LFO, a VCA, a VCF, a VCO, and all that you can see here. And also how they all work together. But maybe we can already see and understand some of the inner workings of a synthesizer right now. Before we look at this default patch in detail, let's first go over the concept of a modular synthesizer in general. If you have a non-modular synth, a Yamaha, Roland, whatever, the cables have already been connected together inside the synth for you. If you go modular, however, in physical form, I mean, you'd have to buy the individual modules plus the cables and connect them together to create a patch, like the one we see here in virtual form, of course. In its physical form, this would be a Eurorack system, where the modules are of a certain height, and it is controlled by actual voltage, electric current, from 0 to 10 volts potential difference. There are other systems, like the now popular Volca modular, which goes up to only 3.3 volts, and it has different cables. It's a completely different system. The Volca is actually semi-modular, so it's functional out of the box with cables already connected, but you can actually repatch it. just like this default patch that loads in VCV2. Similarly, in physical Eurorack format, the Behringer Neutron is a semi-modular synth where you already have all the basic modules built in, but you can also use it as a modular synthesizer. And then the really cool thing is that you can use VCV Rack together with physical synths. So if you want to get into that, you don't have to buy so many modules, but you can still get analog sound. But I'm getting ahead of myself again. There are just so many possibilities. It's amazing. Let's get back to the basic layout and try to figure out what's going on here. Let's follow the cables. Outputs are often labeled black on modules. So if you have a look at the MIDI to CV module, you see that the volt per octave pitch output has a black background around the hole where the cable is connected, and it goes into the volt per octave input on the VCO. The VCO is short for voltage controlled oscillator, and we will learn about that a lot more in the future. But the important thing to know now is that this is the main sound generating module. This is the source of the sound. If you hover over the output, you can even see the voltages that are coming out. And these are now voltages that represent audio signals. And here, if you look at the volt per octave input, you can also see the voltages that are coming in, but these are used to generate the pitch information for the VCO. That's why it is labeled volt per octave. You see we are at 0 volts. If I press this Z button, we are still at 0 volts, and then we go up. And now we are at 1 volt, and we are exactly 1 octave higher. So we have 1 octave for each volt. So that's 1 volt per octave. That's what it's called. And that means if you go up by 10 volts, that you would go up by 10 octaves. So the pitch would be much, 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 much higher. We don't want that. Now, if you look at the other outputs from the MIDI to CV module, you can see that 2 of them are actually going into an oct module, which is called octave as well by VCV. And this module is used to transpose the notes that are coming in, the pitch information from the MIDI to CV module. And here we are transposing it down by 1 octave, or you can go to 2 octaves, 3 octaves, and so on. In case of the first VCO, we are subtracting basically 1 volt from the input, and that goes out into the second VCO in our patch, while the second oct module is shifted by -2 octaves. So from the input, we subtract 2 volts and we go into the volt per octave output. So you can see that we have 1 coming in, -2 is -1. The third oscillator, which is of a different type, is a wavetable oscillator, and it's responsible for the bass here. You can see that it's shifted down by 2 octaves. Actually, let's see where all the cables from the VCOs are going. Well, we have a sawtooth wave going from the VCO into the mixer, into channel 1. And then the second VCO is outputting a square wave, we'll learn about that later, and it's going into channel 2, while the wavetable VCO is going into channel 3. Let's listen to the bass. So if I increase the level on the mixer on channel 3, then the bass should get louder. So let's reduce the volume here first. Well, you could definitely hear that. This module actually, the VCA mix, is responsible for mixing together the different audio signals. you can see them coming in here in 1, 2, 3, and also 4, which is coming from the noise module. We are mixing some extra noise to our oscillators. That's the noise. This is not pitch information anymore, rather voltages that represent audio signals. And if you look at the VCA mix module, we can see that it is a mixer that is used to mix together the outputs from the oscillators. So we have the sawtooth wave from the first VCO, we have the square wave from the second VCO, and we have the output from the wavetable VCO, and also we have some noise coming in, and these are all mixed together in this mixer, and the mix is then sent into a filter. Important to note that this is not pitch information anymore, but actual audio signal. So something that would go from your microphone or guitar to an amplifier or a speaker. These are the signals that your sound card transforms into sound that your ears can hear. So you can see the voltages constantly changing here, and also some blinking, which is absolutely normal. And if we change the levels on the different channels, then we can actually change the sound. So let's try that. That's the main VCO. That's some deeper sound. And that's the bass. And that's the noise. Hey everyone, it's David, aka 2000, this time on video. This is a little intermission. I hope you didn't notice, but the fans on my computer are running really, really loud, and it does interfere with the recording on the microphone, even though it's faced the other way around. I mean, the capsule is facing my mouth and the computer is behind it, but still, I might actually be able to correct it in post, but that's going to take a lot of time and it might ruin the sound. So it's always better to do something about it right at the time of recording. So while we're at it, here's a little behind the scenes of how I record this tutorial. If you look at my setup here, you can see that I have the microphone here. So the sound is going into the microphone, which is recorded into Audacity. And here we have VCV Rack. And now what I'm trying to do is actually control the fan speed. It's already set to custom. So if you see the fan controls, you will see that I set it to 2000 RPM, and that's not allowed at all. Maximum speed is 7200, which is very loud, but that means that I have to monitor the temperature of my CPU, and it shouldn't go over 95 to 100. And well, it's a little bit of effort, but hopefully the result is better quality sound. And now let's continue with the tutorial. I actually have some notes here as well, so let's see what comes next. The noise module is coming next, then the ADSR, then we'll learn about the VCF, then the scope, and so on and so on. We're about halfway now, so let's keep going with this tutorial. I hope the fan noise from my computer is now gone. That's the kind of noise you don't want. But as strange as it sounds, adding some noise to your recording, purposefully, might actually make it better. So, if you look at the mixer, the fourth channel is noise. Let's listen to it, but first turn down the other channels to -infinity decibels. And press any key on the keyboard, so we should only hear noise now, because into channel 4 we have an input from the white noise output of the noise module, which you see is just a bunch of random numbers, which are then transformed into what we will hear now. Okay. Well, the noise is actually going into the low-pass filter where we are modulating the cutoff with this ADSR envelope, as we can see. So in order to hear the noise without all these effects, let's get rid of this modulation, and now we will manually control the cutoff frequency. So we have the whole frequency spectrum. Let's play the noise. We hear nothing, of course, because we are at 30 Hertz cutoff. So if we turn it up, we should start hearing something. And we do. Oh, it sounds like wind. You can actually play around with this and get some really cool sound effects if you want. Maybe in stereo, but that's for the future. Noise is super interesting. As I said before, it's just a bunch of random numbers, and we hear it as we hear it, but you can represent it in various ways. For example, visually, if you've seen an old TV with no signal, you just see random black and white dots, and that's a visual representation of random numbers and noise. And you can see here that you have different types of noise. This was white noise that we have just heard. Let's actually hear it with the filter completely open. Let's turn down the resonance first so that it doesn't interfere with it. And let's turn it up. I'm pressing the key, the Z key on my keyboard. And now we are opening the filter so you can hear what white noise sounds like. And now if we go to pink noise, you can actually hear that it sounds deeper. Now, what is the difference between these different types of noise? Well, it's actually the loudness or intensity of the sound at various frequencies, which are measured in decibels. You see that white noise has a 0 decibel per octave power density, while pink noise has -3, red noise has -6, and so on and so on. Now, the maths is a bit difficult to explain, but extremely interesting. The easiest way to understand this is visually, and we would need a spectrometer for that, so I can show that to you. Unfortunately, there is none as a stock module in VCV, but we can add a scope that helps. Here it is. And we connect the, let's say, the channel 4 output to this. And now we can see what this noise looks like on the scope, the pink noise. And you see that this is white noise. And this is pink noise, what it looks like, and red noise. You can see that it's less dense, so the scope is less filled with these bars. However, I will put up a picture in this video so I can demonstrate better what these numbers mean, this -3 and the -6. They say a picture is worth 1,000 words, so let's see. In case of white noise, you see and hear, maybe, that it's equally loud at all frequencies, so it has a flat power spectrum. Now if we go to pink noise, you can see that the power density falls off. So that means there is less intensity in decibels at higher frequencies. But watch out, the scale on the x-axis, so to say, is logarithmic. So the frequency spectrum of pink noise is linear only on the logarithmic scale. But the so-called spectral power density that we see here decreases by approximately 3 decibels per octave. So you see the slope that is linear going down on the logarithmic scale. Now, if we look at red noise and hear red noise, now, it sounds even deeper. It is also called Brownian noise, so sometimes people refer to it as brown noise, I suppose incorrectly, because the name derives from the Brownian motion, which is also known as the random walk or the drunkard's walk, and it's named after the Scottish scientist Robert Brown, who described this phenomenon in the first half of the 19th century by actually looking at plants through a microscope. I already said it, but the maths of this is incredibly interesting, but we don't actually need it to use noise. To make noise, it's actually quite difficult, but if we just want to use it in our mix, then we go by ear and we can actually filter it and create very, very interesting sounds. So let's continue while we're at full swing. Okay, what is going on? I can hear noise, which shouldn't be there because nothing is showing on the audio module or the recorder module. Anyway, hopefully that's not a problem. Let's turn down the levels here. And let's listen to the noise again. If I push a button here, you can hear the noise playing. And let's try to undo what we did. Let's delete this scope and let's reconnect the cutoff input on the VCF to the envelope output on the ADSR. That's how it was. And turn down the cutoff frequency back to around 30 where it was. Turn back the resonance back up. And I think that's about it. For now, we will only have the noise turned up here on the mixer, and let's listen to it again. Okay, sounds good. You can see here on the ADSR envelope what is actually happening. Here, you have an input from the gate on the MIDI to CV module. So whenever you push down the keyboard, it opens the gate, and you can hear the sound. Also, it triggers or controls this filter. And you can see here on this curve visually what is happening. And I really like it about the VCV ADSR envelope generator. What does it mean, ADSR? Well, you have the attack phase, then you have the decay phase, then you have some sustain, finally the release. So if I push, let's say the Z key, it doesn't really matter which key you push because we are just playing noise, you can see that the attack is going up. If I increase this, it goes up slower. So now the decay, you can control the time of that too. You can make it longer. Now it's going down slowly and slowly, or you can go down quickly. Now you have the sustain. Let's turn it up. So that means that when I keep pushing the button, it keeps it at a higher level, volume, and then the release happens when you let go of the button. Now this is how it works. If I turn the time up here, the sound is going down slower or very quickly. So that's basically what the ADSR envelope is doing. It's at the moment controlling the cutoff frequency of our filter. Don't worry if you don't understand everything. In future videos, I will talk about filters and ADSRs and all of that a lot, but this is just a quick overview of everything. While we're at it, let's look at the VCF module. So we've seen that the ADSR is controlling the cutoff frequency here, and we are getting the sound from the mixer. Let's turn the other levels up. So now we have just noise, but if I turn this up, you can hear from channel 3, the bass from this wavetable VCO. You can see it's going into channel 3. Let's turn up channel 2, the second VCO. This one. And you can see the square wave, or here. And let's turn up the first one as well. Alright, now we have sound, and we can control the frequency where we want it to start whenever we open the envelope. Okay, and then you can actually do it manually as well. This is working as a low-pass filter at the moment, so that means if I'm turning the cutoff frequency up, it lets more high frequencies through, so it only lets the frequencies below the cutoff through. So the higher you turn it, the more low frequencies, the higher the frequencies that will go through. So you can play around with this. You can adjust the resonance. The drive just makes it louder or quieter, so it's a gain knob. It basically does the same as this one here. I mean, for the mix, the mix level. And you also have a resonance knob, so let's turn that up. Okay, so here we are at self-resonance. Sorry about that, which is a very cool phenomenon. Filters are amazing, really, really cool, and we'll learn a lot more about that in the future. We are almost at the end. We have the scope here now, which we have already seen actually. Let's try playing some sounds and see what's happening here. You can see on the scope some visual representation of the sound that is playing. So the louder it is, the higher it goes. And you can adjust the gain knob here. With the gain knob, you can squish it together vertically, or you can kind of zoom in here. We have two channels. We have one input and we have a second input. I don't know, we can input anything here. So you can maybe look at the sine wave from the LFO. Now we have to reduce the time to the speed here, so we can actually see a nicer wave. You see, this is what it looks like. So, and this is our sound wave, and that's our LFO. One of them is a control voltage, the other one is sound, but it really doesn't matter. You can see, you can visualize whatever you want on this scope. And the sound that we see here is not only going into the scope, but it's also going into the audio module. And that audio module then produces the sounds. Our computer is producing the sounds, the sound card, which is going into the earphones and into our ears. And we are actually done with the overview of all of the modules. Did we miss anything from the notes? Where were we? We can now choose an audio driver and device in the audio module that we just covered. And we have used the keyboard to generate notes and play them. So we get to point 3 now. Instruction 3 says that you can drag the knobs up and down to rotate them. Well, we have already seen that. You can just rotate whatever you want here. And if you hold Control or Command on a Mac while dragging it, you can fine-tune. So let's try it with this knob. If I press Command and hold it pressed, then we are making very fine adjustments here. So even if I'm moving my finger quickly, the knob is only turning very, very slowly. So this is fast. and with command pushed, it's very slow. Well, that's easy. Then you can also right-click on the knobs. So if you right-click, we are now at 201 Hertz frequency, but let's say I put it to 400. Then we can exactly tell VCV Rack what we want. That might be useful. Or you can double-click it to initialize, so it goes back to the default setting, back to 261.63 Hertz. And you can also initialize by right-clicking and clicking initialize. Now we're at point 4 of the notes, which say that you can drag ports to create and move cables. Well, we have already seen that. You just click on a cable and keep the mouse or trackpad clicked and then move it around. You can also put it back here if you want. What you can also do is stack multiple cables on outputs by holding Control or Command on a Mac and dragging from an output. What I usually do is that if I want to connect multiple cables on outputs, is that I go from an empty slot, so let's say we have an empty output here, and then I connect it to an input, right? That's the input, and that's the output. So we can go from the triangle output to, let's say, the FM input here. And now we see that we have connected it, and then we connect this one there as well, which doesn't work, of course, but you can't connect two outputs into one input, but you can connect an input into two outputs. So let's say I take an empty input and I connect it to an output that's already been busy. Or you can do it the other way around, but you know, if you click, then you will remove this. So you have to press Control or Command on the output, as it says here in the notes. And then you go and connect it. So we achieve the same result, as you can see. Also, one more thing is that if you click and then click again and then click again, then you see all the different color options. So if you like to color code your cables, you can do that. Also, I think if you right click on a hole, then you can select the color that you want. Now we're at point 5 of the notes, which says right click on an empty rack space to add new modules. We actually have done that already at the beginning, but let's do it again. So you right click and you select a module that you want. Let's say we pick the LFO, the low frequency oscillator, and now it is placed here, and we can, for example, connect that, the sine wave, to the input here, and then we see a nice sine wave. It looks like we have actually finished the entire basic patch. Which modules haven't we covered? Well, the LFO and the VCA. So we will look at those next, and then we're almost finished. But first, a quick note on performance. Up here you can see the FPS at which your screen or window is running and the average and maximum CPU usage. I actually had to restart my computer just a second ago because it was overheating, unfortunately. But, just restart the machine and it usually fixes the problem. That's what the IT guys say. However, if you want to further reduce the strain on your processor, then there are various things you can do. We already talked about the block size here, which you can access if you right-click on the text here, and then you can increase it or decrease it. The higher you go, the less strain you put on your processor and graphics card, because this is actually just like a video game. So it uses your graphics card to draw all these images and also to produce the sound, I think. So what you can do is if you go here to View then you can reduce your frame rate. So we can go from 30 Hertz to, let's say, 60 Hertz. And now I want you to watch the top right corner. So we are going to 60 Hertz, and it should increase the CPU usage. We have so few modules that it doesn't make much of a difference right now. So let's just go back to, I always keep going to engine, but we have to go to view, and then we can go to frame rate 30, back again. Also, another thing that you can do is actually here in the engine, and you can select how many threads you want to use. And if you use only one core of your CPU and one thread, mine has 2 cores and 4 threads, then you get the lowest CPU usage. Also, you can display the performance meters for each module. So let's click on that. And then you can see how much of your processing resources each of the modules is using. So if you have one module that is maybe using all your processing power, you can just get rid of it. But it looks like we don't have any issues at the moment, so let's continue with the tutorial. The next module we are going to look at is the LFO, which is a low frequency oscillator. It is an oscillator just like the VCO, which is a voltage controlled oscillator. The main difference between the two is the frequency. In the VCO, we have now 261 Hz selected. So if that produces sound, that would be a C note. The LFO right now is at 2 Hz. So if it's connected to the scope, as you can see, so we can actually visualize the sine wave here. And if we go down to 1 Hz, so I enter 1 here, then you see that the wave is going slowlier. And if you count, it's like 1, 2, 3, 4, 5, 6, 7, and so on. So you get 1 full cycle each second. That's what 1 Hertz means. So if we go to, let's say, 4 Hertz, then you will be 1, 2, 3. Yeah, it's difficult to count, but you get the point. One interesting thing, like what we can do, for example, is we connect the LFO output. As we have learned, we push command or control, and first we disconnect the audio module and the recording module, and we connect the LFO to the audio module. The input to the output, and also here the input to the output. So we actually record it. There's something happening here. Can we hear it? No, I can't hear anything, but somehow this is going up and down. Let's turn up the frequency. 17 Hertz. 30 Hertz. I think you can hear it. I mean, I can hear it. We can go up. I think we need a mixer first so we can control the volume of this. So let's disconnect this again. And this too. And then instead of the noise here, let's go into the mixer from the sine wave and also to the audio module. We need to go from the input to the output. I keep messing this up all the time. This is the input, okay. And this is the output. So we are going from the LFO to the mixer, and then from the mixer, we are going once to the audio module so we can actually hear something, and also to the recording module because I want you to hear it too, not just me. And I'm going to mix this all together. So where were we? We are at 0.6 Hertz. You can see it. Let's turn this down. And let's turn this up a little bit. Now we can control the volume. And let's start turning up the LFO. And at some point we get to audible frequencies. So we are at, let's go to 261 Hertz. And now what's happening is that the LFO is producing exactly the same frequency as the VCO. So this is just an oscillator like the other one, the difference being that it can go down to up 0.004 Hertz, whereas this one goes down to 11 Hertz. So it's in the audible sort of frequencies, depending on your hearing. And this one is just really, really slow compared to the VCO. We have arrived to the final module in this tutorial patch, which is the VCA. At the moment, the VCA is connected to the mod wheel output of our MIDI to CV module, which is just outputting 0 volts at the moment, so nothing is happening here. But if we disconnect it, then it's at maximum. So let's remove this. And now you can actually control this manually by pulling down the level here. What is this doing? Well, it's an amplifier. It's a voltage controlled amplifier. So it amplifies the signal, or it makes it bigger. I mean, for example, if it's sound, louder, or quieter. If it's some other kind of signal, control voltage, it also multiplies it or divides it. So that's what it does. And we can control it manually, like we did, or through this CV input. We had the mod wheel output connected, but we can connect any other module. So let's try it with the, let's say the LFO. Let's connect the sine wave here and turn up the LFO a little bit. And now we see that the level is going up and down, up and down. And we can control the range here. So now we are actually only going to 50%, whereas on the scope we are going up to 10 volts. Here, if we have it at 49.6%, we are only going up to 4.96 volts. I mean, that should be the case. So let's... that's the input, right? Let's hear what's happening here. I don't know if I play a sound, what's going to happen. Oh boy, yes, we are modulating for sure. We have this, instead of a mod wheel, we now have the LFO modulating the sound. It sounds quite interesting, so let's turn it down. You are also going through the ADSR as well, so, you know, remember that. It's kind of a lot of things happening at the same time. If it doesn't all make sense to you, don't worry about it. We're going to look at all these modules in more detail in the future. We will start with oscillators, and then we'll get to filters and amplifiers and all that stuff. But for now, we are actually finished with all the modules in the tutorial patch, so we should be able to make music now. However, the kind of music I like to make is not playing on the keyboard, rather using a sequencer. So what we can do now is look at some other modules in the default library that are not included in this patch. So let's add a sequencer now. If we right-click or double-tap on the trackpad, we see all the available modules here. So let's add the sequencer. And instead of getting the volt per octave pitch output from the MIDI to CV module, we are actually going to find the CV output on this sequencer, which is here. And we're going to reconnect all these cables right here. Now, we have no sound, of course. Why? Because the gate is outputting 0 volts, so we are not opening the gate with every push of a button. Well, maybe it actually works. So if I push a button, it's going to open the gate. Oh yes. And then if you change the notes here, it's actually going to play while you are pushing the button. It sounds terrible, you know. This. Okay, enough of that. Let's get rid of this gate. Let's reset everything. How do we do that? We right click and we click initialize. So that we don't have some crazy sounds coming, and we connect the gate output to, well, there is a trigger output here, which is not a gate output. The trigger is like a gate, but it only goes like pop, pop, very quickly. So we can actually look at that on the scope if we want. Let's disconnect this and let's connect the trigger input here and then see, you see little spikes. That's not really what we want. We want a gate that actually opens for a longer time. But with the sequencer, the SEC3, in this VCV2 version, there is a trick. If you right click and you select clock pass-through, then you are actually getting a gate output. So you see that the gate is opening longer, and you can also see it with the blinking here, that the green light is on for a longer time. The sequencer has a built-in clock, so the tempo is set to 120 BPM. You see the blinking here at, 2 blinks per second, because it's 120 beats per minute, so 2 beats per second. We are set to 8 steps at the moment. You can see the steps going here down with the lights as they go 1, 2, 3, 4, 5, 6, 7, and 8. And well, we still don't have any sound. I wonder why. Well, I suppose it's because the ADSR envelope is not open. We actually have to connect this gate output also here, and then we should be hearing some thing. Okay. Wow. Okay, this is not exactly music, but well, it sounds absolutely terrible. So let's disconnect this. The CV input here. Okay, I'm sorry about this horrible noise. I think we're done with the sequencer now, because we'll have to add a quantizer now in order to not just get random notes, because, you know, if you turn this, it's going to sound even worse. So let's let's turn down the volume completely and add the quantizer next. In order to add the quantizer, you right click and you find it among the basic modules. Here it is, a 12-note quantizer and scale selector. Okay, so what we do is that instead of going straight from the sequencer into wherever we are going, we first will go through the quantizer. So let's see where the CV is going. It's going to many different places. So we repatch this here, the outputs. And now we'll connect the output to the input of the quantizer. So first is going in here, then something is happening within this module, right? It's quantizing the notes that we have selected here to a scale. So we have to actually select the notes that we want. We deselect all the notes if we want, and then select the ones that we want to hear. So so we have the clock, the CV going in, we have the triggers. We don't have any sound though, so let's try to figure out why not. let's go from the end. We have the input. Here we have 0 volts. That's not good. Here we have 0 volts. That's not good. Here we have 0 volts. Aha! Of course, we turned down the mixer. So let's turn it back up. Let's turn down the tempo. Ooh. Let's deselect everything, just one note we keep. So now you can select the scale you want. Let's just do the C major scale. Just select all these notes here. Oh boy. Oh boy. Well, we have a long way to go until we are actually making some music, because, you know, this is unlistenable. Oh, what? Oh, let me turn it down. What can we do now to make this sound a bit better? Well, let's think. Okay. I did think, and I had some coffee, and what we are going to do is build a patch from scratch, hopefully quickly. These things usually take time, but I don't want this tutorial to be too long. But before that, I will show you how to save and load your patches. So if you go to File, Save As, just like in any other program, you can save your patch so that you can load it later and keep working on it. Or if you're finished, you can share it with other people, like I do, for example. I usually share my patches on patch storage, and this patch will be shared there too. So check it out, the link will be in the description. So what you do is you select where you want the patch to be saved. The default location is within the VCV2 folder in the patches subfolder, and you give it a name. Let's call this untitled, and then you hit save. And it says untitled.vcv already exists. Do you want to replace it? You say no or cancel, and let's call this untitled2 then, and then you hit save. And if you want to reload it, then you go to File, Open, and then we have these two files here, the untitled file and the untitled2. So if you double click on this, then it will reopen the patch. Now, let's get rid of most of these modules here. We will need the recorder. We'll need the audio module. Let's keep the scope, and let's get rid of everything else here. So you just select all the modules that you don't want to keep and then hit backspace, or the other option is that you right click or double tap, and then from this menu you select delete. And what I really liked earlier, but first I see now here in the audio module we have some weird output. So let's go to built-in output so I can hear whatever will be playing. So what we'll do is we'll build a patch with the wind noise, because I quite liked it earlier, but we'll try to make it stereo. So what do we need for that? The sound source, that's where it all starts, will be the noise module. So you right click on a blank space and then you find the noise module. Here it is. So the sound will be coming from here. We'll use white noise, and that will then go into a filter, and we'll feed that into a mixer. And because we want stereo sound, and this mixer is mono only, we'll actually need another mixer. So let's duplicate this one. And let's say that this will be the left channel, this will be the right channel. And we connect now the outputs once to the audio module, the left or mono input here, and second we'll connect the same output to the recorder module, and then we'll do the same with the right channel. We go from here to here in the right input and also the right input on the recorder. And now if I start building this patch from the beginning, we'll start with the sound source, the noise, and we'll feed that into the audio input on the filter. So we have audio signal coming from here to here. And just to visualize what this signal looks like after the low-pass filter, which we will now feed into the first mixer. Okay, we have some mono sound and in the left ear. And also we would need sound in the right ear. So for now, let's just feed the same output into the other mixer, and now you can hear in both ears. But the sound is mono because we have the same source. I mean, you have two channels, but they are the same. And if you... Well, you can't hear anything because I haven't started the recorder. So let me do that and then you will hear. But I will first turn off this filter. I lower the cutoff frequency and I will hit record now. And now if I open the filter, you will at some point start hearing something. When we get to audible frequencies, sorry, I stopped talking. So at 400 Hertz. We are at 200 Hertz. Okay, so what we want is this kind of sound effect here, that we're opening the filter smoothly and then closing the filter smoothly. So it kind of sounds like wind. However, we want this to happen automatically. So what can we do? Well, we want this to go up and down, up and down. And for that, an LFO is perfect. So let's add the LFO. Connect that to the scope so we can see what's happening. Assign output in here. Now let's reduce the gain. This is just a visual module, so it's just squishing it all together. We still can't see the top, but we'll change the offset here so it's more visible. Let's turn down the gain even more and move this to 0 here. So now you see that the LFO is working, and let's turn it down a little bit. Now it's going a bit slower. We know that we can reduce the time here, so that only visually, of course. So now we can see this nice sine wave. And what this will do, if we'll connect it if we connect it to the VCF, is that it's going to move this cutoff frequency up and down, up and down, up and down. So to do that, instead of doing it manually, we'll connect this sine output. We press Command or Control and connect it to the frequency input here to modulate the cutoff frequency. Now it's not doing anything because we are at 0%. But let's say we set this to 200%. I right-clicked on the knob and I type in 200 here. We are now at a lower frequency. However, if I open this frequency cutoff CV knob, then it's going to start moving it up and down. Now it's open, so it's up and down, up and down. So it's doing up and down. Let's say we set it to 20%. That means that we'll be going from 200 Hertz to 240 Hertz, but it's a bit fast, so let's turn the LFO down. So now it's opening the filter. And now it's closing the filter. Let's reduce this a little bit. Let's reduce this cutoff frequency. The starting point. Now we are adjusting the starting point. So when it's at 0 here, then we're starting from a lower starting point. And that sounds quite okay. However, we are still only mono, so we have the same sound in the left and the right ear, and that's just fine, but I would like it to be stereo if we already put these two mixers here. So what we'll do is we'll delay one of the audio signals, so the one is going to the left ear, and then let's say the one that's going to the right ear is going to be delayed. And for that we'll use a delay module. So I say delay. And well, it's called a delay. And that's what it does. It delays the audio that comes in here in the audio input. So instead of the low-pass filter going into both mixers, we'll first feed it into the delay. Let's say into channel 2 for now, or we can just use the same channel if you want, but then the sound will cut off for a moment. So we feed this in here first, and then the mix output will go here. And there's a wet output and there's a mix output. Basically, you can mix together the original signal, audio signal, with the delayed one, but if you turn the mix up to 100%, then it's basically the same as the wet output. So now we have nice stereo wind noise. You can play around with the knobs now to find the settings that you like, and that's what usually takes a lot of time, and you play around with this. So let's increase the delay time a little bit. Let's reduce the LFO frequency. And find the settings which we like the most. I'm actually quite happy with this, so I will save this patch now. And as we know, to save a patch, you go to File, Save As, and let's call this Wind. And now we have saved the patch, and we can continue with this tutorial. We don't have much left. I will now tell you about a couple more modules, and then we are finished. One of the modules I would like to mention is the MULT module, so let me add that. And what this module does is that if you feed in a signal, then it multiplies it, as the name suggests. In VCV Rack, you don't usually need this because you can just patch in multiple cables into one hole, but on a physical Eurorack synthesizer, you can't just do this so simply. You have to multiply the signal. So how that would work is that instead of having two cables coming from the same output, you would first feed it into the MULT, and this one too. And then you would come from here back to where we were, so here and here. And now we have the same signal coming from both of these outputs. Generally, this is unnecessary in VCV Rack, as I said, but I wanted you to know about this as well. And now the next thing I would like to tell you about is more a visual thing, because I like my patches not just to sound good, but also to look good. So we can clean this up a little bit, maybe like this, so it's so nicely together. It saves some space. So what you do is you select the modules that you want with the mouse, and then you click on them and drag them. Keep the mouse button clicked, of course, and then you drag it. And now it's already looking much better, but what you can do if you have an empty space and you don't like it, if you want this to look like a rectangle, is that you use the blank module, which is just a blank panel, as it says here, and it's also resizable. And that's fantastic, because if you move this here, then you can click on one of its sides, and then you can pull on it, and it makes it nice and wide, the size that you want. So now we have a nice rectangle. And actually, what I want, it's basically a white box, and that's what I want to tell you about. And this is a bit more abstract. It's kind of a metaphor that I want to tell you about. It's how to think about these patches. Well, first you have an input, but actually we don't have any inputs here. So what we are going to do is we are going to stop the recording now, and I will open a new patch, and I will explain it there. To open a new patch, you go to File, New, as we already know, and oh, we didn't save this. Let's save this first. File, Save As, and let's call this Wind Final, and then save. And now, well, it's great that VCV notifies us so that we don't forget to save our patches. That would be a big mistake. So let's now open a new patch, and we get the basic patch again that we already know very well. And here I can explain to you better these inputs and outputs and this metaphor that I want to tell you about. Basically, here, what's happening? First, we select the audio device. So it's built-in output. I will also add the recorder back. And we'll feed the mono signal in here. Well, what is the last stop at the moment? It's this one. There's nothing coming out from the audio module. Well, the audio module feeds this information to our computer, and that's coming out of the speakers or earphones into our ears. But when it comes to this patch, there is nothing more coming after this. So this is the last station. and it's coming from the low-pass filter. So let's add the MULT that we just saw. And instead of the built-in output, we'll feed it here first. And then we'll output it once to the audio module and once to the recorder module. And now we are in mono. And also, let's add a blank again, so that it's a nice rectangle. Perfect. And now let me tell you what I wanted to say for a while. Here you have the input. What is our input? It's the keyboard. So if let's start the recording now, and we'll save the recording as, let's say, white box. And I press a button on the keyboard from the bottom row, let's say the Z key, then we hear sound, right? And it's coming from our keyboard. That's the input. And then from this, a lot of things are happening here. And finally, the sound comes out in our earphones or speakers. And if you have studied some physics or electrical engineering, computer science, then you know that people talk about black boxes. So what is happening inside a machine is kind of hidden. You only see the inputs, something is happening, and then you get the outputs. And inside is the magic. And well, this is the magic that we are talking about. However, for us, it's not magic anymore because we built this box. So we know what's going on inside. But for example, another person who just hears our music playing, so if I press the keys like, then they are wondering, how did you produce this sound? Why does it sound like this? And of course, if you change some settings, it will sound differently. However, we open this box, and usually it's called a black box, but let's call this a white box because it kind of looks like a white box or rectangle. And we are building the black or white box in this case. So for us, it's no magic anymore. And it's our responsibility and our job to build this. But the people who are listening to our music, they don't need to have an idea about what's going on here. All they care about is the sound and the music. But for us, this is incredibly interesting, hopefully, and very complicated. And that's why it takes so long to explain how it works. And I hope this helps you in your thinking about modular synthesizers, because that's kind of how I think about it. And with that, I would like to congratulate you that you got to the end of this video. And let me tell you about the future plans and how we are going to continue with the tutorials. This is music. Well, it doesn't quite sound like the songs I make yet, but you can't really learn that in one video. At least now you know the basics. If you want to learn how to make better music with VCV Rack, feel free to check out my video, How I Make Ambient Music with the VCV Rack, where I talk about my philosophy of composing and recording music, and I also walk through a simple patch, a bit more advanced than this one. A quick summary of that video and my philosophy is that I look at VCV Rack as having three functions. One, to generate pitch information, that is composition, so like writing sheet music or playing the keyboard, as we attempted in this video. Second, to create instrument sounds for the lead, the chords, the bass, drums, percussion, whatever. Third, I use VCV Rack to mix the different instruments together and shape the final sound and record my compositions. You can, of course, do further work in other audio software, but I always try to do as much as possible inside of VCV Rack so that I can get my music out as quickly as possible. So, the plan for next year. My New Year's resolution is that I would like to make one tutorial each week, and the music as it comes to me. You can't really force that, just go with the flow. For the tutorials, well, I have a video about my top 10 favorite modules, which I made about 3 years ago. Feel free to check that out, it's quite beginner friendly, but I would like to expand on that and present one of my favorite modules each week with a little bit of background about that type of module and how it works. We'll start with oscillators, naturally, which is the source of the sound and the heart of every synth. And we'll look at the even VCO by Befako first. Also, please let me know in the comments what modules you would like to hear about. And let's continue with the tutorials this year and learn VCV Rack together. Don't forget to subscribe. Thank you and peace.